We saw how to set up a simple class with its own custom overloaded plus operator, and now we'll take a look at how to set up a overloaded equality operator. So this is an operator that returns a Boolean true or false. And so it compares two things. It has a left-hand side and a right-hand side. If the two things on the left and right are equal, then you return true. If they're not equal, somehow that's based on your criterion, then you return false. So like the plus operator that the book talked about, this is a standalone operator. It has actually two operands because it's not part of the class itself. And so just like with the add operator, which was a standalone operator in the book for the money class, I'll just flip back to it right now. Here's the overloaded plus operator, and the book introduces it not as a member function but as a standalone function outside the class. And as you saw before, it has two operands, and this one that they're going to do next in the book is also a standalone operator. That is it sits outside the class. It's not part of the class itself. Okay, but it uses the class the money class. So the equality operator equal basically allows you to compare money objects. Just like we added two objects in the last example, we can use this equal operator to compare two things. And the left hand side is this one, amount 1, the right hand side is amount 2. Okay, and what it returns is a Boolean, either true or false. Okay, so this once again, it's important to stress that there's two ways to set up these functions. One as a member function, which we did in the last video for the plus operator. The other way is as shown in the first part of this chapter 8. That is, they show us how to do non-member functions. I like to do member functions a lot of the time, and so that's why in the last video we saw a member function or member operator. Okay, so here it is. It's not that complicated. So it seems like a lot, but no. So you use, this is going to sit outside the class. You say that there's an operator called equal. We're overloading it with two parameters, or we're going to supply it with two arguments. And basically what you want to do is just return either true or false. It doesn't really matter exactly how this is done for now. If you want to take a look at it, take a close look. It's doing something that's sort of makes sense. You take the dollar amount and check the dollar amount for the first or the left hand side of the equal operator, equal operator, compare it with the right hand side dollar amount, and do the same thing for the cents part. Okay, so you should be able to do this either as a standalone function like this, or as a member operator like we did in the last video. Okay, so I'm hoping all of that is straightforward, and now we'll take a closer look at some of the things that we used. So remember that constructors actually return objects. We like to think of constructors as not having a return type, and we sort of think of constructors as a void function. But no, these are special. So constructors are special functions with special properties. They can actually return a value. That's how we think about it in C++ at least. And this is true, essentially true in Java as well. There are some slight differences because in Java we only use the heap. In C++ we can use the stack or the heap. So there are some slight differences, but basically the same idea. And remember that in the return statement in the plus overload for money, we actually return what looks like a new object, only here we don't call new, and that's important. We just say return and then name of the class and then the number of required parameters for whatever constructor that you're using. So what we're returning is an invocation of the money class. And the constructor actually kicks in and returns an object. And this is called an anonymous object. And we saw how to do this for when we redefine an object, right? We can always call the constructor to redefine an object. Okay, and later on we will use this in combination with new as it's done in Java. So some of you might be thinking, shouldn't you have a new here? Well, later on we'll look at how to do that. Right now we're not going to do that. Okay. So let me just go back and I'll show you the version that I set up for this simple ABC object. So if you look at the plus operator, here it is, you're just returning ABC. So in effect, we're just calling the constructor and returning an object. And that's what we're supposed to do. We're going to return a const object in this case. And if you were to look at the book, the first examples will be standalone functions, as we saw, and here it is. Here's our return money object. Okay, I'm going to go back to where we were. Okay. So this is called an anonymous object. We've used it before in other situations, and I'm hoping that you can understand what we're doing here with the return. So take a look at this plus operator overload again. Remember, if you look at the code, what you'll see is that we return money, but also note that we are returning a const. And so we know that we're returning a const object, something that we cannot change. And you might say, why? Why should we return const? It turns out if you don't do a const, it'll work. But there are certain problems you might run into. So consider the impact of returning a non-const object. So take out the const. You can do that. And then you say, let's say you do an addition in this case, M1 plus M2. So remember, the whole reason why we're overloading operators is so that we can do things like supposedly add two objects. So M1 and M2 are money objects. The object return is a money object, and we can quote-unquote do things with objects, that is, call member functions. Let's say we call a member function where we modify the result of this plus operation. So then, we might possibly run into problems. So it depends on what those methods do. So the whole problem is we can call member functions of the result of an addition. So we could invoke a member function on the object returned by this expression M1 plus M2 like this. We can just say, since M1 plus M2 is an object, we can put parentheses around it and say dot output. So output, let's say, we haven't shown it, but let's just say we're assuming that all it does is print to the console. In that case, it's nothing is a problem. It doesn't really change anything in the sum in the object that M1 this addition returns. However, let's say we call something like this, M1 plus M2, parentheses around it, dot input. That is, let's say we get input from the user, and now we've added something, and then once we get the result of the addition, we're asking to, let's say, read something from a file or get some input from the user and change the sum. That would be a problem, because then it would be very hard to debug some situation like this. In this case, we can actually see that we're calling a member function that might modify it, but we might have some more subtle situations where we add something, but the result is not exactly what we expect from an addition. That would be a problem. So it would be legal, that is, C++ would allow it, but it would be hard to debug. And so that's why if we have a situation where we have modification of some anonymous object, you should not allow it, just so that your programs are easier to debug. So when we say things like, you can't allow that here, what we're saying is to make our programs a little bit more understandable and easier to debug, we shouldn't allow that. And that's why we define the return object as a const. So it's not to satisfy the compiler or anything. It's actually, we use that const just to make our code that much more bug-free. Okay. You can also overload unary operators. Remember, with binary operators, if you have a standalone function, we have two operands. With unary operators, if you have a standalone function, we have one operand. So for example, negative, or I'm sorry, minus, unary minus, like saying x is equal to minus y. Let's say they're ints. If y is 5, then x will get the value minus. If y is 5, x will get the value minus 5. Whatever is the negative of y. So if y were already, like say, minus 10, x would get the value 10. Right? Just negate the sign. We can also have other unary operators, plus plus, that is pre or post increment, and pre or post decrement. And these operators can also be overloaded. Let's take a look at how to overload the unary minus. And we'll take a look just like all the other just like all the other functions we've been looking at. We're not going to put it inside the class. We're going to place it outside the class definition. That is, it's not going to be a member function. It's going to be outside. So you can guess what it'll look like. We always return const just to make our programs that much more bug-free. And we say operator minus, we don't need money ... because this is outside or a standalone function. And we have, in this case, we have just one argument or one parameter for this function. So this will distinguish it from the subtraction operator where you would have two operands. So we can overload it that way. So even though it's the same, it looks the same, we can have two different functions, one with one operand, that's the unary minus, and that's a standalone function, and then one with two operands, that would be the subtraction operator. Okay, so can't stress this enough, for there's only one argument because this is the unary operator. And so you can have two operators, you can overload the minus operator twice, one for the binary subtraction operator, which will have two operands, and so two arguments if you have a standalone function, and then one operand for just one operand or one argument for the unary minus. And so you have to have definitions for both. So all you have to do to implement unary minus is this is reasonable. You could do, of course, you could do anything you want, but here would be a reasonable thing to do. You get the dollar amount for this operand, negate it, and then get the cent amount for this one operand, and negate that, and use that to create a new money object and return that. Okay, pretty straightforward. I would think this would be the natural thing to do. If you want to call unary minus on a money object, we're just going to negate everything. Okay, so we know, this thing is known for all the built-in types, so ints, floats, doubles. We know what it does. All it does is return the negation. And so if dollars was 5, this would give you a -5, and same thing, something similar for cents. You create a new object with negative amounts, assuming that that's allowed, and then you return this anonymous object.